I'm in the middle of building a 100% custom, made from scratch, 3-link rear suspension for my 1998 all-wheel drive, LS-swapped, Pro Touring style Chevy S10 pickup truck. And we're converting from leaf springs out back to a multi-link, 3-link rear suspension with coilovers. And we're about 2/3 of the way done. Everything is custom. There's a ton of fabrication involved in this project, but along the way, I've gotten a ton of questions, many of them the same, about why I'm doing things a certain way. So I figured rather than individually answering them all down in the comments, I'll just make a quick video and help explain my thought process. Now, just because it's my thought process doesn't mean it's right for everybody. There's maybe some mistakes I'm making along the way, which you could catch, but I'm just gonna answer the top 10 most common questions about why I'm building a 3-link and maybe why a 3-link is the best rear suspension, asterisk, for what I'm doing. So let's jump right in. Here's the list of 10 questions. Number 1 is the big one. Why did I choose a 3-link over a 4-link? And the simple answer is, 1, because I've always wanted to, but 2, it just has to do with how much space we have available. See, this S10 is a compact truck, and from the factory, the leaf springs are mounted underneath the frame rail, just where I have the lower link mounted. And number 1, that's important because when I have my tires on here, there's about, I'd say maybe 2 inches of space between the inner frame and the inside of the tire. So if I had the links mounted on the outside of the frame, there just would potentially be some rubbing going on. For the lower links, not a big deal. We can tuck them under the frame just like we did from the factory, but for the upper links, again, space. There's just not a lot of space out there for 1 link on each side. Now, the other thing we could do is mount the upper links on the inside, just touching the frame there and there, which is an option. However, there's a fuel tank that sits there, which is going back. There's a charcoal canister there, and I'm gonna have some exhaust running here. So there's not a lot of space. So that's kind of the main reason, packaging, why I chose to run a 3-link. Now, a 4-link obviously is probably, is the most popular performance-based solid axle rear suspension. People put them in everything. There's tons of adjustability, but from an adjustment standpoint, a 3-link basically has all the same options, just has 1 fewer link. So mainly that's why I chose a 3-link. We'll talk about adjustment in a little bit. Moving on to question number 2. Panhard bar over a Watts link. And some people were asking, did I forget to put one on there? Well, no, the suspension is not done yet. We need some sort of axle centering device. On a 3 or a 4-link suspension, especially only a parallel design, meaning where all the links go in a straight line front to back, there's really nothing that holds the axle from moving left and right. These links have so much side play in them, like literally the axle just can, move left and right. So 2 choices, Watts link or Panhard bar. A Watts link is quite complicated. It pivots in the center of the differential. There's a left and a right link, both mounted to the frame. And as the suspension cycles up and down, the axle stays perfectly centered. There is 0 deflection side to side, where with a Panhard bar, it's a single rod that pivots. Let's see if I can give a quick demonstration live here. Let's say it pivots there. That would be the frame. Let's imagine this is the suspension. The suspension goes up and down. That end stays fixed. So there will be an arc that this moves in, and therefore a tiny amount of lateral deflection. With the length of the bar that I'm going to be running, which is pretty much from frame rail to frame rail, the amount of side-to-side movement with a Panhard bar is not minimal, but it's negligible. I think probably less than 1/4 of an inch. Realistically 3/16 or so. I'll put the calculation up on the screen of how much side-to-side movement we have, but that's the main reason why I chose a Panhard bar. Simplicity, and it really won't be moving all that much. Now, if we had a really long travel suspension, maybe we readjust it. But for what I'm doing, a Panhard bar is gonna be just fine. Most of the OEM link-style suspensions like, 4th gen Camaros, the S197 Mustang 3-links, they'll use a Panhard bar. I know the Panther chassis, Crown Vics, they do use a Watts link, but it's a little bit more complicated than I really need, and I definitely can live with that minuscule amount of side-to-side movement. So that's why I chose a Panhard bar over a Watts link. Question number 3. This has to do with the rear axle. So I have a lot of questions. Again, why did I run this particular axle? Why don't I use a Ford 9-inch? What about the Ford 8.8? Well, those are all great axles. The Ford 9-inch is like the ultimate hot rod rear axle. You can get it in practically any width you want, any wheel bolt pattern, but the problem is gear ratios. There is no exact match to what I'm running up front. Remember, all-wheel drive, we have a 373-to-1 ratio up front, and the closest thing in a 9-inch, I believe, is a 370. Now that is probably within 1%, which maybe isn't that big of a deal, but it's a big deal to me, even though the 9-inch is the strongest axle pretty much in this, call it weight class. Ford 8.8 is also another great axle, plenty of gearing options, and I'm pretty sure you can get a 373 in a Ford 8.8, which I could have done. But here's the reason why I chose this rear end. This is a 8.5-inch GM 10-bolt axle, which number one, has the exact same gear ratio that I have, 373 to 1, so it matches front to back. Number two is the width. This is from a Chevy ZR2 S10, which is kind of their high rider off-road compact truck. And this axle is like 5 inches wider than the original one, which is awesome for me because I'm running a Corvette wheel that has a high positive offset. So realistically, the wheels don't stick out beyond the fender. Most S10 guys build two-wheel drive trucks and they have more of like a drag pack look where they have a deep dish wheel out back and they need a narrower rear axle. So for all those reasons, that's why I chose the 8.5 10-bolt. And then there's the question of strength because yes, I know the 8.8 Ford and the 9-inch Ford are very, very strong axles, but consider this. The 8.5-inch 10-bolt is the same exact rear axle that would come in a half-ton Silverado, just like the ugly truck, my big block, turbocharged, 5,200-pound burnout machine that can run 10-second quarter-mile passes. That truck runs an 8.5 10-bolt, which is essentially the same exact axle as this. So I know it's going to be more than strong enough. So that's why I'm not running a 9-inch or an 8.8. Next question on the list. Did I do the math on the instant center? Now, yeah, the short version is of course I did. I spent a ton of time planning out the geometry. It's getting hot in here, I turned the fan off. Planning out the geometry of the suspension before I started cutting or unbolting a single component. If you're not quite familiar with instant center and anti-squat, I won't go through all the details right now, but effectively it has to do with how the two joints interact with each other. So if you draw an imaginary line forward to the lower link, it comes here, an imaginary line through the upper link, it intersects in this point right here. That is the instant center, or the point about which the suspension will react. Now, this imaginary line from the bottom of the tire all the way up through the top, that is I think that goes through the center of gravity. And that's called the anti-squat line in effect. But again, I don't want to get too much into that. But yes, I did do the math on instant center and anti-squat. Here's the numbers I'm shooting for. 75% anti-squat, rounding of course. Instant center, 74 inches ahead of the axle, 11 inches above the ground. So that's where my instant center is, but I also have left enough adjustability in the links, both top and bottom, to dial that in because let's say I want the truck to transfer weight onto the rear tires by lifting the front end, we can do that. That's where it's set now. Or if I want to separate and push the rear axle into the ground, we can do that by adjusting some bars and giving ourselves a more positive anti-squat, like 125%. So that's the answer to that question. Yes, of course we did the math. 5, custom suspension versus Caltracks, because a lot of people had commented that why didn't you just install Caltracks? It would be so much simpler and it would solve the problem of wheel hop, which I was trying to fight from the beginning. And yes, 100%, Caltracks would be an easy bolt-on solution. They're inexpensive and it would solve more or less all of my problems. So I could have done that. However, one, I don't love Caltracks in this application because they would stick down below the springs, which used to sit somewhere in here. So there is ground clearance to consider. But number two, and by the way, I do run Caltracks on both my four-wheel drive drag truck and my two-wheel drive street/drag truck. So I do love Caltracks. But I've always wanted to try building a custom rear suspension. So that's all the justification that I needed. But yeah, Caltracks, they're a great option, especially if you want something that bolts right on and you don't have to do any welding. So there's that. The sixth question has to do with why is the upper link not in the center? That's a multi-part question, but number one, it's a space issue because with that upper bracket there, in order to give me the adjustment and suspension travel that I wanted, see if I can show you this, not a great angle, but I didn't want this link bracket to crash into the drive shaft. Obviously that would be no good, so I offset it. Now the follow-up to that is, how is this going to react with the chassis? Because there's a tension force on this link under acceleration, and theoretically it's going to be pulling on the chassis a little bit unevenly, but this is where my suspension knowledge isn't quite as good as I wish it were. But everything I read tells me as long as it's offset close to center as possible, which I did. I moved that as close to the drive shaft as I dared. And also, as long as it's on the passenger side, this will do the best to help counteract some of the chassis twist under acceleration, because the drive shaft from the back is going to be spinning counterclockwise. It's going to be applying a bit of a lifting force on this wheel. That's why if you have a single tracker rear, usually it spins that wheel. Anyway, if you have the link on that side, it's going to do a better job of counteracting that lift and some of the twist. So that's probably the least educated answer I'm going to give you today, but that's the way I understand it. Question number 7 has to do with reinforcing the frame, and this again stems from, I'm sure everybody's experience with the S10 platform, but especially after seeing the slow-mo video of this truck while it was wheel hopping, because the whole truck was just shimmying and shaking back and forth. So question, why don't I box the frame? Well, one, the frame kind of already is boxed actually. From this point here all the way up to the front, it's boxed, it's welded together. Side note, some of the welds aren't awesome, so I am going to be reinforcing it. But to me, I don't really see a huge need to apply even more reinforcement to the frame when it's already fairly strong. And also, the lower links, that's where the suspension is going to be pushing on the chassis. That's where all the forward force is going to be. Now, speaking of reinforcement, this fuel tank cross member here is 2 halves that have been stitched together from the factory. The back was welded most of the way. The front was welded only here. So I took some time and I fully welded this in, front to back, side to side, welded it to the frame rails, both top and bottom. And then I went ahead and I built this super beefy 1/4 inch bracket. So again, this is in tension pulling backwards. So this is fairly strong. Other chassis reinforcements I probably will do, the ZR2, not the ZR2, I'm sorry, the ZQ8 S10s. They did have a slight reinforcement between this bed mount and that bed mount to help tie the chassis together so it doesn't twist so much. I probably will do something like that, and then maybe go, or well, if I do that, I'm definitely going to go from the face here to this cross member. We have to build around the fuel tank and stuff. So that's the answer. One, the frame is already boxed from there all the way ahead. Pretty sure that's only on 4-wheel drive trucks. So it's pretty strong, but I will probably do a little bit of weld reinforcing. So I think we're a little bit more than halfway through our list. Question number 8. Oh, that's a good question. This has to do with not the suspension, so we'll take a quick detour and come right back. It has to do with the engine that we're building for it, a 5.3 LM7 or a truck quote-unquote LS as they call it. The question was, why didn't I pull the heads? Why didn't I put new cam bearings in? Why didn't I put new lifters in? And some of the predictions were that this motor would only last about 5,000 miles because I did not do that stuff. So take that in 2 pieces at a time. First half, why didn't I take the heads off and put new head gaskets and all those other parts? Number one, this is sort of a temporary motor. Yeah, I get it. It doesn't quite make sense. Like, why go ahead and reseal and put a cam and do some valve train upgrades, you know, the trunnions and the springs, in a motor that's only temporary? Well, that's easy. I don't want to put it in stock. Like, no one swaps a stock engine in. But number 2 is temporary. Down the road, I want to build something bigger and more powerful. So I didn't want to go through the extra effort and expense to put in new lifters, where realistically the lifters in there I think are going to be just fine. I know we did have some irregular wear on the push rods, but that was only on the tops of the push rods where they meet to the rocker bodies. That's why I replaced the push rods and all of the worn out rocker arms. All the bottoms, every single one of the 16 push rods where they went into the lifter, perfect. The little ball on the end, not a bit of wear. That's why I felt okay running the original push rods. Cam bearings, yeah, pretty much any LS that you open up, the cam bearings are toast. Again, I didn't really feel it necessary. Maybe I'm wrong, maybe you guys will be right and the engine will only last for 4,000 or 5,000 miles, but hey, we'll find out. And if it does fail, I'll be the first one to make a video about it and let you know that you were right. But I have a hunch that may not happen. Yeah, so I think that kind of answers that question. But sort of a temporary motor, but you can't put one in stock because Tim Allen syndrome. All right. Number 9, Sendcut send method. What does that mean? The question is, back on suspension, why did I not design a 100% from scratch, computer designed suspension, like have the brackets laser cut on a plasma or a laser cutter, using a company like Sendcut Send? When I built the suspension for the 4-wheel drive drag truck up front, that's exactly what I did. I designed the spring towers, I had them laser cut, and I welded them on, and I'm really, really pleased with how that turned out. The short version, or the short answer to that question is, I am not as experienced with modeling software as I used to be. I believe it or not, took mechanical engineering in college. I used to be pretty dang good with some modeling software. I haven't done it for probably 15 years. I'm out of practice, and it would take me probably 2 weeks worth of time to figure out how to get the modeling software to cut the brackets that I wanted. That would be a better route, and someday I promise I will get there. I'll figure out how to do all that stuff, and I even want to get my own CNC plasma cutter. But for now, I was able to use all these off-road parts that were, I spent a lot of time shopping around to find ones that would do what I wanted. But this has the geometry that I was after. Remember, we modeled this before in an Excel spreadsheet, but it has the instant center and the anti-squat that I want, and I was able to do that with off-the-shelf brackets, albeit ones that we had to cut and modify to do what we wanted. So someday I'll get better at that modeling software. And I believe the final question of the day, this has to do with the weight of everything, because these are very heavy brackets and links designed around, like, say, a rock crawler or a Jeep or something like that. 2-inch OD, 250 wall, solid, not solid, but steel lowers, and then the Panhard bar is a 150 or 1.5 inch OD, 250 wall. So everything is very, very heavy. It's very, very strong, but that does put a lot of weight on the frame, and half of that is unsprung weight, which is not generally something you want in a vehicle that's meant to handle well. So it's overbuilt, which I love. It's a little bit heavier, which I don't necessarily love, but to me, that's not really a deal killer. And so the original question, will I ever do anything to make them lighter? Yeah, maybe someday I'll go through and I'll rebuild the links. But my main concern right now is just to get the suspension working, get it put together, make sure the geometry reacts the way that I want it to. And then down the road, if I decide, hey, this thing's just a little bit too heavy, we can go ahead and replace those super heavy wall links with something that's a little bit more manageable. So also the style of joint, that's it's an 1.25 inch Heim joint. They may be a little bit noisy, so maybe we put something different on there with, like, instead of a 1/4 inch wall, maybe we do 1/8 inch wall, chromoly, I don't know. Well, we'll figure that out. Short answers maybe. So pretty much, guys, those are the 10 questions that I got a ton on my suspension videos, and that's the best answer that I can give you. I have no idea how this is going to work. That's the truth of it. I've done tons of research, and I've built it to the best of my ability, but at the end of the day, until we get it out on the road or on the track, I have no idea how this is going to work. But I think it's going to work pretty awesome, and I am really excited. So sorry for the ramble-a-thon, guys, but in the very next video that you see on this truck, we're going to be pulling the axle back out, building the shock brackets for the lower, building the shock brackets for the upper, and then probably building the Panhard bar bracket. So thank you for watching, and thank you for enduring my questions. If you have any further questions, feel free to drop them down below. I will answer them to the best that I can. Come back soon, guys.